Hi everyone, I'm Dr. Subbarao from RVIT Institute of Technology. In this video, I'm going to explain the construction, working and cell reactions of methanol-oxygen fuel cells. This methanol-oxygen fuel cell is a device which converts the chemical energy of methanol and oxygen into electrical energy through spontaneous electrochemical reactions. So this one works on the principle of electrochemical reactions, which means it is having the oxidation and reduction reactions. That is redox reactions. This is the methanol fuel cell. This is the methanol oxygen fuel cell. Now coming to the principle. The principle involves oxidizing methanol at the anode and producing protons, electrons, and carbon dioxide. The protons passes through membrane to the cathode, where they react with oxygen to form water. And the electrons flows through an external circuit which is generates the electricity. So this is the principle of methanol-oxygen fuel cell. See here, what is happening at an anode, the oxidation reaction takes place, and at cathode, the reduction reaction takes place, and which generates the electrons. They flows through the external circuit and generate the electricity. The overall cell reaction is methanol react with oxygen to form carbon dioxide and water. Here CH3OH plus 3/2O2 gives rise to CO2 plus 2H2O. So I am repeating again. The overall cell reaction is, here we are passing the methanol and oxygen. So the methanol react with the oxygen and converted into carbon dioxide and water. So this is the overall cell reaction of methanol-oxygen fuel cell. Now coming to the construction of methanol-oxygen fuel cell. It mainly consists of the electrodes, anode and a cathode. Here one inlet for circulating the methanol, and here this one is the oxidant inlet. Here we are supplying the oxygen gas, and another one is the electrolyte. Here this is the porous membrane used as a electrolyte. And next one, last one is the electrical circuit. This is the electrical circuit. First one is the anode, a porous electrode where the methanol is oxidized. Typically, a platinum or ruthenium catalyst is used to facilitate the reaction. That means here we are using the platinum ruthenium catalyst as acting as a anode. The next one is the cathode, another porous electrode where the oxygen react with protons and electrons. So here for cathode we are using the graphite electrode. So the graphite electrode, the porous graphite electrode, which is acting as a cathode. This electrode absorbs the oxygen gas, and the oxygen gas react with the protons and the electrons. Here the reduction reaction takes place and forms the carbon dioxide and water molecules. Next one is the electrolyte. So in between the anode and cathode, we are using a proton exchange membrane that allows the proton to pass but it blocks the electrons. So the proton exchange membrane allows protons only, but they restrict the electrons flow, and the electrons are enter into the electrical circuit. So this one is for electrical circuit, we are using the copper or aluminum. So this one collect the electrons coming from the anode and sent to the load. Load are the external circuit. So the electrons again enter into the cathode region. Here fuel. At anode, we are circulating the methanol. This one is in aqueous form. That means it is in a liquid form. And next one is the oxidant inlet. Here we are sending the oxygen gas. Now coming to the working of methanol-oxygen fuel cell. At anode reaction, the methanol and water react at anode in the presence of a catalyst producing carbon dioxide and hydrogen ions. And also it loses the electrons. CH3OH plus H2O gives rise to CO2 plus 6H plus 6 electrons. That means methanol react with the water to form carbon dioxide and releases protons. Here it releases the protons and the electrons. Now at the proton transport, the hydrogen ions generated at the anode passes through the electrolyte towards the cathode region. And the next one, cathode reactions. So we are supplying the oxygen gas at cathode, which will react with the protons and electrons. So the protons and electrons coming from the anode. So the oxygen react with protons and electrons at cathode region to form water. So 3 by 2 O2 plus 6 H plus 6 electrons gives rise to 3 H2. Here the oxygen gas react with the proton and electrons to form the water. So this is the happening at the cathode region. Now the electron flow. The electrons are generated at anode, travel through the external circuit to the cathode region, which is providing the flow of electricity that can be used for the power devices. And coming to the overall reaction. The overall reaction in methanol and oxygen fuel cell is the oxidation of methanol by oxygen to produce carbon dioxide and water. So CH3OH plus 3 by 2 O2 gives rise to CO2 plus H2. So this is the working of methanol-oxygen fuel cell. Now coming to the cell reactions. At anode, oxidation reaction takes place. Oxidation means loss of electrons. Here methanol reacts with water and forms carbon dioxide, protons and electrons. At cathode region, reduction reaction takes place. That means the oxygen react with the protons and electrons to form water. So this is the cathode reaction. And coming to the overall reaction, we are adding the anode and the cathode reactions, which means methanol react with oxygen and produces carbon dioxide and water. So this is the overall cell reactions. This is the working of methanol and oxygen fuel cells. Now coming to the differences between primary, secondary and fuel cells. So these are the partitions. This is the future. This is the primary cells, secondary cells and fuel cells. The first one is the rechargeability. So the primary fuel cells are not rechargeable and the secondary fuel cells are rechargeable. And the fuel cells produces electricity continuously. So by supplying the fuel, it continuously produces the electricity. So they are not rechargeable. Now coming to the energy storage. These primary cells stores chemical energy and the secondary cells stores chemical energy. And these fuel cells convert chemical energy from external fuels. And coming to the electrolyte type. For primary cells, it is usually paste or dry. That means the electrolyte is a paste material, paste type or dry material. And coming to the secondary cells, we are using liquid or paste as an electrolyte. And in fuel cells, we are using the solid materials or the liquid electrolytes. So solid means polymer exchange membranes. So they are the solid type. Liquid means alkali KOH, potassium hydroxide electrolytes. And next one, reaction reversibility. The primary cells are irreversible reactions happen. And at secondary cells, reversible reactions are happen. And fuel cells, reactions are continuously but not reversible. And next property is external fuel supply. For primary fuel cells, we are not supplied any external fuel. That means no need for the primary cells. And for secondary fuel cells, here also we are not supplying any fuels. And in fuel cells, it required the passage of external fuels. That means hydrogen or oxygen or methanol. So we are passing the external fuels through the circuit. And next one, heat generation. For primary fuel cells, low heat energy will be generated. And for secondary fuel cells, moderate heat energy generated. And for fuel cells, low to moderate heat energy will be generated. And coming to the working duration. For primary cells, short term use, that means one time use only. After completely discharging, the battery cells will be thrown out. And for secondary fuel cells, medium to long term. So this is the medium to long term working duration. And for fuel cells, long term continuous operation. That means if we continuously supply the fuels, it will continuously produce the electricity. So long term usage, we can use the fuel cells. And next one, environmental impact. These primary cells often contains toxic chemicals. That means manganese oxide, like we are using the toxic materials. If we thrown out, which will polluted the environment. And next, coming to the secondary fuel cells, this can be recycled. That means we are not throwing outside. This can be recycled and used again and again. And coming to the fuel cells, these vehicles these environmentally friendly materials. That means oxygen and hydrogen, they are environmentally friendly materials which doesn't release any harmful gases, or it is emitted the low emissions. Next, coming to the applications. These primary cells are used for the flashlights, remote controls and clocks. And the secondary cells are used for the mobile phones, laptops, EVs and UPS. And coming to the fuel cells, these are used in vehicles, spacecrafts, backup power systems. So these are the common applications. Coming to the examples of primary cells, dry cells or Leclanche cell, and also zinc air batteries. Coming to the secondary cells, lead acid batteries, lithium ion batteries. These are comes under the secondary cells. Coming to the fuel cells, hydrogen oxygen fuel cells, polymer proton exchange memory cells. And the next one is the methanol-oxygen fuel cells. These are the examples of fuel cells. So thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.